afternoon. Thank you for coming. Today we have the second lecture of Professor Margolisi. For people who first attended this event, Professor is head of intercellular interaction division in one of the institutes of National Institutes of Health in United States. It's National Institute of Child Health and Human Development. And I think the first draft version of the title was a little bit different, so why we still can't defeat HIV. But the final one, I think it's more interest. So please, Professor Margolisi, visit us as part of the Fulbright program. So please ask the question after the presentation.
Thank you for coming this Friday evening. I hope that I'll tell you such interesting stories that you would not regret that you missed something in the Friday. And thank you for interest in science. I always remember that we did in my university, we made seminars Friday evening starting at 7. So that's made a selection between people who really like science more than anything else and people who do not. So you obviously belong to the first part. So the name is slightly changed, what we know and do not know, but have to know to fight HIV/AIDS and other infections. But the meaning is the same what was in my original advertising. Let's start from something pretty long. That is the town of Siena in Italy. In the 14th century, it was one of the greatest city in Europe, with people living there. The population was equal to Paris. There were many investments, people like their leaders, and it was very beautiful. And it's really flourishing with money, with all kind of production, and with art. Then came a tragic year of May 1348, when some people become sick. Not many, and at first nobody noticed it, but then more and more people become sick with some particular disease, and people start to die, and that was disaster. And that was disaster not only for Siena, but also for entire Europe. Just to give you what's happened in Europe, in July of that year, 1347, with a ship which brought this infection, and you understand that's plague, the population of Europe before this was increased little by little. From year 1000 it was 38 million, to that year when this ship boarded in Genoa, in 1347, there was 75 million population of Europe. The next time, in 1352, the population was equal to what was in 1100. So basically, in 200 years, the population didn't come back to the level which was in 1352. That was a real disaster, and also disaster for Siena, which at that year, they planned the highest cathedral in Europe to build. If somebody goes to Siena, it doesn't match Paris. Population is very small now. It's a nice Italian city, and the cathedral still stays unfinished, the way they tried to do it before epidemics. So that was history. And of course, nowadays, in our times, we so much believe in science, in medicine, that nobody thought that something similar would happen in our times. And that is why nobody pays attention to a small report of the disease, which was published in 1981 in a very small CDC, Central Disease Control Weekly, which nobody reads except few specialists. And it's reported about in Los Angeles about a strange disease which in 5 young men which have some pneumonia, which is looks very strange. Happened these 3 men were homosexuals. So, and nobody would expect what developed from this June 8, 1981 in the world. And so what developed that 84.2 million in human population were infected, and 40 million died of this disease, which nobody paid attention before. So to compare with COVID epidemics, the infection was more people were infected, but the death was about 7 million compared to 40 million, so 5 times less. So what happens in recently? The latest, I think, data is from 2020, maybe 2021, I may mistake. So during this year, still more than 500,000 people died from the disease, in spite of all efforts for all these years to treat it, to prevent it. 38 million are infected. Among them, 1.5 million were new infections just during this year. So epidemic continues. And it continues everywhere through the whole world. And if somebody thinks that it's only African epidemics, it's wrong. 90% of the cases are outside of Africa, so in Europe and the United States and other countries. What's in Georgia? In Georgia, as I found, for the same year, 8,000 are infected, which is not tragic, but it's not small. Most of them are in Tbilisi, but estimation is that more than 10,000 are infected but do not know about the infection, so they deliberately unknown spread this infection further. And the majority of patients are between 25 and 39 years, but that's the majority. There is pretty much many outside. And in that year, 2020, there are 700 new infections, and most of them are in Tbilisi. And if you think that it's homosexual infection, you're absolutely wrong. That is how it's split in Georgia. So almost 50%, the thread, are regular heterosexual contacts. And the other major part of it is injection of drug users. I'll tell you why it's so much. And basically only 11% are through homosexual contact. So most is developed as... The disease is for long is not about homosexuals. It's about general heterosexual population. So why over these years, from 1981 to now, and even in Georgia, we didn't manage to fight these epidemics? And that's basically the topic of my lecture today. Here is the virus itself. It's a human immunodeficiency virus, HIV. I don't know how you call it in Georgian. Do you know the name in Georgian? Okay. Some countries has its own name. So in French, for example, they translate it from French. In Russian, different. So in most people call it HIV. It's human immunodeficiency virus. It's a small virus of 100 nanometers, you can imagine. It's covered with bilayer lipid membrane. There is a core proteins inside, and RNA. It's not DNA, but RNA is inside this virus. So it's dramatic, of course, that so many people died and continue to die of AIDS. But for some reason, dramatic is not only virus, dramatic is not only the disease and death, but the story, the history is dramatic as well. I don't know why, with dramatic in disease and virus, the history becomes dramatic. So the main contributor to discovery of this virus is Robert Galla from the Institute. At that time he worked in the National Institute of Health in which I work now, American scientist, and Luc Montagnier, a French scientist. Their role in HIV discovery is very much different. And they have important, of course, their students contributed to this discovery. That is Mika Popovich from Gala's lab, and François Barré-Sinoussi from Luc Montagnier lab. She looks different now, unfortunately. So Gala was a great, and remain, he's alive, very much active. He's director of the Institute in Baltimore. He's the greatest probably virologist of our time. His discovery goes beyond HIV. He discovered the first RNA virus and also continued to study HIV. And with the help of Mika Popovich, he developed a system of lymphocytes, which you can, some of us probably use here, everywhere is used, which you keep in culture. So to discover virus, you need a system in vitro to infect with this virus. You need the cells which are sensitive to this virus. And he managed to develop based on lymphocytes. Interesting enough that at that time, it was mid-80s, RNA virus were not studied because people, all scientists, most of the scientists believe that this virus doesn't affect humans. It's not in humans. It was discovered in 1910 by Patton Rouse, and it was chicken virus. And Patton Rouse continued to study it. Actually, it's important to live long. He got Nobel Prize. It's a record in Nobel Prize laureates. 65 years after he discovered it. So important to be alive at that time, since Nobel Prize is not awarded after you die. So Mika Popovich and all funding agencies, including Europe, United States, didn't pay money to study this virus because a funding agency focused on something which is a danger for human health, not for chickens. And the only place where it was studied really was in Czech Republic, in Prague, by the guy with Jan Svoboda, a great virologist, also very famous for his discoveries, because in Czech Republic, it was under communism, they give very little money to study, but on the other side, they don't bother what you study. You can study whatever you want, as long as it doesn't contradict the communist reading and Marx and Engels and Lenin, he can study whatever he wants. And he continued to study uniquely these RNA viruses. And RNA viruses are very much different from DNA virus. When you infect cells, DNA virus mostly gives some lesions, so cell die, and there are some plugs you find. While RNA virus, cells don't die, but they may crisscross. Cells go on each other and makes a typical culture. And Mika Popovich, who worked in Jan Svoboda, knows this, and probably Gala didn't know this, as didn't know most of the scientists. So when the new disease started and the virus was, the blood was isolated and brought to Gala lab in the United States, with help Mika Popovich, they understood immediately that that's a virus and not DNA virus. On the other side of Barré-Sinoussi, who was basically a technician in Montagnier lab, he worked on electron microscopy and found this virus, which he saw first time in electron microscopy. But to discover virus is not enough. You need to test that it's infectious, and for this they use Gala's system, and Barré-Sinoussi even came to Gala lab and somehow brought this virus to Gala lab. There was some kind of difficult story or confusion, so Gala published his results with some viruses, including, I think, this virus, and Montagnier blamed him in plagiarism. That was a huge scandal, which goes all the way to the Congress of the United States, who set the special committee to discover who discovered the virus. And Gala was ostracized. And at that time, it was very important because not only for science, but because diagnostics was made on the cells which Gala developed. So it was a claim about patent. And this Congress actually absolved Galla that he didn't steal the virus, so he continues to work. But who discovered virus and who has power of the patent, that was all argued. And it came to the presidents of the country, first time in history of science, who came together. It was Chirac and Reagan, and discussed who discovered, to whom the patent belongs. And of course, unlike scientists who continue to argue, politicians are always too compromised, and so it decided that it would go to both countries. And from that, it continues. Also, the main patent is still by American company. So that is the story of this dramatic story of discovery of this virus. What's about virus itself? So actually, Nobel Prize was awarded not to Popovich, not to anybody else, but to Barré-Sinoussi, who was a French, who deserves this, and Luc Montagnier, who argues that he became, so Galla continues to contribute to virology a lot. He discovered another virus, while Montagnier becomes sidelined, and actually he died recently. He spread some absolutely crazy story about COVID, about infection, about artificially designed virus, which completely against science. And unfortunately, Barré-Sinoussi was awarded this prize, which I think she deserves it. And actually, even you go back to the history of discovery. So Barré-Sinoussi, as I told, was a kind of electron microscopy technician in the lab. And at the time they first published, Montagnier said, don't study this virus, go study something more important, like herpes virus, which they studied before. And the team has convinced him, or actually go against his will, to continue to study. He was the lab chief. And when they published first paper, they discussed who will be the first authors, or other contributors to the paper. And okay, so at that time, Barré-Sinoussi didn't have a permanent position at Pasteur Institute, where they all worked, and they decided to put her in the first author, so that probably she can get, with another publication, she can get a position, which actually they got a slot for her. Since then she works in the slot. And actually, years later, Nobel Prize Committee just looked at the paper and looked who is the first author. The first author was Barré-Sinoussi. The last author was Montagnier, and they awarded Nobel Prize, and they didn't give the Nobel Prize for Galla. As all the prizes, Nobel Prizes are given to the people who deserve it, but not to the old people who deserve it. So there was a big argument. We wrote a letter to Nature, everybody signed it. I also said that Galla also deserved it, but that happens after all announcement of Nobel Prize every year. Some people rightly say that you awarded Nobel Prize to people who deserve it, but another Dr. X, Dr. Y also deserve it because they made foundation for this discovery, and Nobel Prize never argues. It never goes into any discussion and keeps silent, as happened in these particular cases. So, dramatic and interesting. So let's go to virus. Why HIV has so success? Actually, I think I like viruses, and also HIV is of course evil. I think it's a masterpiece of virus. It's really the best diabolic virus I ever learned about and studies. It develops absolutely perfect strategy to distribute among people, to transfer from people to people, and proof of it, these millions of people who were discovered. What is the strategy? One of the strategy is slow infection. So a person, human being, becomes infected, and for weeks it looks like a small cold. So CD4 lymphocytes, the main aim of this virus, it goes slowly down, but in the first weeks it doesn't go. Virus is very high in the blood, but immune response really doesn't start. So with small disease like some cold, flu, nobody goes to the doctor to test. And that is the strategy of this virus. And then it developed for years. For years, a person doesn't know that she or he is infected unless you go to test with PCR the viral RNA. But who goes there? And virus then, moreover, after a few weeks, it drops in the blood. So for many years, it is very difficult. Now you can, but in that time you cannot. It was PCR was not that sensitive. You cannot find this virus in blood. The person feels a little bit not healthy, but really not much. And then 10 years, 7 years after, CD4 T cell drop, and that's the real disease. A person progressed to AIDS. So this is one strategy of the virus, because some virus, like Ebola virus, they infect a person in the morning, in the night, in the morning the person is dead. And that's why it happens in some African village, but it never went to the epidemics, because the person dies before there is probability that this person transmit virus to another person. Well, here, virus has years and years to be transmitted to another person. So that's one of the strategy. Slow infection. Another strategy is, of course, cell targets and way transmitted. So the main targets of this virus are lymphocytes and macrophages. That is exactly the cell which built our defense against viruses. That's immune cells, so it targets immune system. So that's a kind of infrastructure of our body. Like in revolution, people say that you should destroy some kind of now internet in the old times of the network of railroads, and then the country becomes defeated even without tanks goes into the country nowadays. So that's another strategy of the virus. Also, virus used another strategy. It's like a sleeping agent, a spy. You know that in countries plant some spies in other countries which sends, like KGB sends to other countries, and the person stays as a real citizen, lives, marries, has children, and nobody knows. And it's no difference between behavior of this person and regular citizen, until he or she is given an order, and then she tries to transmit some sensitive information. That's exactly what happened with the virus, strategy of virus. So it infects lymphocytes, and most cells die after a certain period, or we can now have some drugs which can treat person and the cells which infect and produce virus dying. However, there is one sleeping agent, a silent reservoir. One cell, approximately per million, becomes infected and keeps silent. It doesn't produce virus. The virus is inside, but from the surface, as the immune system works from the surface, nobody can understand that the cell is infected and virus inside. So immune system and all our treatments are useless because the cell keeps silent. But from time to time, these cells release virus and you become reinfected inside. So you don't need outside infection. This silent reservoir wakes up and sends it to the cells, you become infected again. Another strategy of this successful strategy is that it goes mostly through sexual contacts. So when a woman becomes pregnant or a spermatozoa comes into the ova, spermatozoa brings new proteins. So basically, that's like transplantation. A pregnant woman who has some fetus carries some transplant with foreign proteins. So if you transplant something into your heart, onto your spleen, without any drugs, that is rejected by the body. Here, there is a special niche in women which prevents this rejection, because a new fetus growing in the body, and this part of the body has special mechanism which now pretty well studied with T lymphocyte suppression, which prevents in normal system rejection. Otherwise, nobody will be sitting here, and I wouldn't give you a talk because would be rejected as eggs, fertilized eggs from our mother's body. And virus uses it because if it would infect other organs, some slow, but nevertheless some immune response would be developed. However, here, when the virus infects through vagina, antibody response and immune response is prevented. So virus has time to infect and discriminate through the body. That's another strategy. Isn't it great that a virus can invent an evolution so multiple strategy? So sexual transmission. There is another strategy, which even more striking, that rate of mutations. So HIV is a retrovirus. Retro is not like we're going to retro movies, doesn't mean the old virus. Retro means it comes from RNA to DNA, unlike most of the biological process in our body who come from DNA, then RNA is built and proteins built from RNA. Here it goes the opposite way. So actually Svoboda was one who discovered this. So it comes into the body, then RNA comes out of the virus, RNA enters nucleus, and then copied into DNA and integrated into the DNA, and then from DNA it again comes RNA, proteins forming new virus, and virus comes out. So DNA, RNA to DNA, there is a special enzyme, has a lot of errors in copying RNA, viral RNA to human DNA. Normally, biology is built on very precise mechanism. That's why we look similar like our mothers, our fathers, our grandmothers, because spermatozoa brings to the egg its DNA, and it's copied, very much precise, only slightly different. And here, the nature, that's the principle of all, otherwise will just disappear. But this principle, which is absolutely ubiquitous for the nature, is here the strategy built an opposite situation. So that, by the way, is different from other viruses like COVID, like SARS-CoV-2, which some of you have disease. SARS-CoV-2, also RNA virus, it's in fact similar fuse with the membrane, but it doesn't go into a nucleus. So when virus is cleared from your body, that's it. It can be some pathological process, but the virus itself, after a certain period, doesn't exist in your body anymore, while HIV would stay for entire life, because it's silent reservoirs. Of course, cells are dying, but the longevity of the silent reservoir is 75 years. So you stay all your life with virus inside you. So here, HIV reverse transcriptase makes 3 errors per million nucleosides. So 10 virions are somehow different from the virions which infected. How much is this? It's also, now we come to astronomy numbers. If you look to Milky Way, you see some stars in the good night. In Tbilisi you can see it because it's too polluted, but if you go out, you see it. So how many stars you see? With the naked eye, when you look in the night, that are approximately 10 in the 4th stars. However, if you use a telescope, that is like Milky Way, that's what we call fog. If you go into observatory, use telescope, you see 10 in the 11 with good stars. Astronomical number which you cannot imagine. And here is the number of viruses every day are generated in infected human body. With all the errors, you can difficult to imagine these numbers, but basically, in a few days, the virus is very much different from what person is infected. And also, immune response, like for all viruses in our body, develops over time, slowly, but the immunity developed against the virus which are infected too. While in a week or 10 days after the immune response develops, you have already different virus, very much different from initial one. So it's like saying that generals are always prepared to the last war, not the future war, but the past war. Here the immune system does exactly the same. It responds to the past virus, but cannot foresee the future virus. And that's another great strategy of this virus. So I can show you visually what's the variability of the virus. If you each new several sequences you add to this tree, there is variability of a global influenza virus in 1996. For the whole year, it was big epidemics. The virus becomes different, of course, but this way. And here is what HIV during 1 year in the Republic of Congo during the same year, 96. You see what the difference in the strategy of these two viruses are. So let's go to infection. How people are infected with the virus. We know that part we pretty much know by our experiments in vitro. So lymphocytes, there are CD4 lymphocytes, the main fraction of lymphocytes which fight viruses in our body. And it was known for several years after discovery that HIV specifically infects CD4 T lymphocytes. However, more recently, later, it was discovered that CD4, it's not enough to bind virus. You need another receptor, which is called co-receptor, which calls CXCR4. So the virus binds to CD4, but needs another receptor to bind, so it's two receptors. Then it can fuse with the cell and open its RNA to the cell. Also, there is another, that called X4 virus. Also, there's another type of the same virus, R5, which uses also CD4, but another co-receptor, CCR5. And somehow this blue virus normally comes first. So a person is infected by this virus, blue, and little by mutation, it comes to this red virus. So prophylactic, you mostly need to prevent infection of R5 virus. It was found that some humans are not infectable at all because they have deletion in the gene which encodes the CCR5 receptor for R5 HIV virus. It's deletion of 32 nucleotides called delta 32, and these people are not infected at all because the virus has no receptors. Interesting that this mutation goes only the white population. There is no such mutation in yellow race, nor in the black race. So basically this mutation developed after the humankind was split in different races. So people argue and interested, so why this mutation still exists? Of course, there should be some infection, epidemics in the old history, which made this mutation to support, and maybe this mutation, somehow people who developed this mutation won in this old epidemic. What kind of epidemics? Nobody knows. There was a hypothesis that the plaque epidemics, which I started with, maybe it also CCR5 somehow plays a role, but that was never confirmed. Actually, CCR5, these people, of course, who were studied from A to Z, were absolutely healthy people. No pathology was found in these people who are this delta 32 mutant. Recently, it was found that they are more easily infected by West Nile virus, one of the viruses, mostly in the United States. So we don't know what's developed, but we know that some population is resistant to HIV infection. Basically, nature also took care of our resistance to the virus. This virus, which infects lymphocyte macrophage, has to go in the blood to infect. If you put it on skin, nothing happens. Skin prevents, and mucosal prevents this virus to go inside the human body. So nevertheless, it's successfully infected. So, and that's the answer why homosexuals or anal intercourse is more dangerous than vaginal rectal. So vaginal mucosa is built of multi-layer cellular, while rectal mucosa is built by only one layer of epithelia. And unfortunately, most of the women nowadays, due to pollution and some other problem, have some lesions in this mucosa. It's not as beautiful as his, there are some holes. And rectal mucosa is even more sensitive. That's why virus can easily go with high probability with anal sexual act, while vagina is much less efficient, but nevertheless we go. If you go to the routes of exposure and infection, so you see sexual, here's the number of the probability of being infected by one sexual act without any prevention. So the highest, of course, is transfusion of infected through blood, because all the barriers, and there are multiple, not only epithelia, there are some defensins, some molecules which prevent viral to be infection. As you see, but when you put a needle into your body and the needle carries infected virus, you overpass this what nature made in evolution defend us against viruses. You go into blood where all the targets of this virus are macrophages and lymphocytes. Also, the vertical mother-to-child infection is very high probability, 25%. And this is, by the way, the greatest success of our science, because now it goes close to zero. In developed countries is 1%, because all drugs which you give, you cannot give to people long because they're toxic, but for a week you can give it. And it turned out that the womb protects, placenta protects virus from going to infected mother into the fetus. So the fetus is infected during the birth. When there's a canal, the fetus has some blood taken through the mouth. So if you give to the mother for 2 weeks this drug, and it's more or less safe, before the birth, there is almost no risk of the child to be born with HIV. That's, I think, the greatest. Also, we can have some drugs which prevent HIV infection, but mostly what treat infection. So in spite of these numbers, which will look very small, as I started, infection goes very wide. Because although they are small, but human beings are very sexual individuals. Unlike animals, we don't have seasonal breeding. People have sex during the whole year, and more or less often. By the way, the studying of this disease really changed everything in the world. So some sexual problems which our grandfathers and grandmothers couldn't even discuss. They go under the pillow. Nowadays, it's open discussion in TV, around the dinner table, and it's very good because the problems should be discussed to be solved. So, actually, this also is about sexual behavior. So, and we know a lot about psychology of human sexual behavior just because of HIV studies. For example, there were legends about more sexual nations, less sexual nations, how the French are more sexual, or black people are more sexual. Turned out complete nonsense. People now know all the statistics. All races, all nations have sexual intercourse approximately with the same frequency, an average 8 times a month. So let's come back to the virus. The virus consists of only about 10 genes. Very simple virus, much simpler. For example, herpes virus, the virus which you have some pimples in summer, has 1,000 genes, 10-fold more. So we know everything about these genes, just everything, we all sequences. We know all proteins which are encoded by this virus, by these genes in this virus. We know the targets of this, as I showed you. You know the targets, most targets of this virus inside the cells. So it looks like I know almost everything. Unfortunately, and we know that in fact lymphoid system, lymph nodes, which are the main in our body nodes which keep all these macrophages and lymphocytes. How we know almost nothing as of now, how what starts the disease. We know that these lymphoid organs are destroyed in these years, and that's you become immunodeficient. You die out of opportunistic infection because you're infected without lymphoid system, without immune response, not from HIV, but some other virus of which uninfected people do not die. And to our shame, we know very little about the mechanism of this phenomena. That's the difference between molecular biology and medicine, real medicine or physiology, because molecular biology is a very simple system, simple science. It is most or less linear. And here we have three-dimensional system, and every mathematician will say you that it's several orders or more complex to study three-dimensional compared to one-dimensional. And finally, another strategy of the virus, cell activation. So virus can replicate only in activated cells. But it has such a diabolic ability. It infects the cell and makes it stimulate, and also it immune activate neighbor cells through some mechanism. So virus prepares other cells to be target of the next generation of virus. Also, some other viruses which present in our body are not very dangerous, like herpes viruses, they activate our system, and that makes us more vulnerable to HIV. Actually, our immune system is not sleeping. It's always go like the army goes to maneuvers to be prepared for invasion. Our immune system never sleeps. It's always sometime goes up and down to be trained to prepare for the virus. And this is cell activation, which makes them as a target. So I told you about this virus. We know the cycle of this virus. As I already told you, it comes, fuses with the cell membrane, go inside, RNA is released, it goes into the nucleus, DNA is read from RNA, inserted in the chromosome for entire life in one of million cells, and then RNA are read, protein are composed, and virus is assembled inside the nucleus, inside the cell. And all these are governed through the different enzymes which we know, and basically quite an efficient, I would say, already many years, treatment of people are developed. So there is called ART, antiretroviral therapy, and it's composed of a mixture of inhibitors of all these receptors, 3, and also now a more inhibitor of the fusion mechanism was developed. So under this treatment, nowadays an infected person can have more or less normal life. And it was a hope that that was the resolution of the whole epidemics and the whole system, because there are many diseases like diabetes, for example. We can't cure diabetes, but people are treated with insulin and keep alive for many, many years while diabetes is still there. That's called not cure, but technical cure. People thought that the same would happen with HIV individuals. And this story was not true. And the example is how important is immune activation. This is a tale of two monkeys. So monkeys have similar SIV virus, simian immune deficiency virus, different from HIV. They're not cross-infected. You cannot be infected with a monkey virus, and monkey virus is difficult to infect with HIV, although possible. And there are two types of monkeys, in New World and in Africa. And rhesus macaques, if you infect with a virus which made out of human HIV genome, but the outer membrane is different, develops a disease similar to humans, AIDS. While Tsuchi-mangabis don't develop anything. And people thought that what those monkeys, maybe they're not infected. maybe CD4 are resistant. And they made a whole list comparing these two monkeys, and turned out the only thing which is different, certain monkeys cells are not immune activated. They don't go into immune activation, and that keeps them alive. So, like we say in English, ignorance is a bliss. So it's like humans, some humans, let's have some family problems, some depression, you cannot go to the work, you cannot work, and some have divorce or something very terrible, but nevertheless go and continue to function as without. So this is an example of two monkeys. One is immune activated, one is not, and that's a proof that immune activation is important for disease development. So when we developed, my colleagues, developed this antiretroviral therapy, we hope that it will resolve all the problems. So HIV, if it's infected and not treated, a person dies from opportunistic infection. As I told, there are other viruses or bacteria which enter this weakened body and got infection, mostly from lung disease. So there was no wonder why when HIV infects people, there are some different disease, opportunistic infection happens, mostly cardiovascular disease, cancer, and some other diseases. Because all the diseases, now it's a fact, are one of the cofactors of development of this disease is this immune activation. It's immune activation, there are different levels of immune activation. One, which when you fight, for example, a cold, influenza virus, you have, or other viruses, you have a burst of immune answer, and then the virus is deleted from your body, you clear it, and normally immune system should come to the background, but sometimes it doesn't come, it has a little bit above the normal level. That calls immune activation now. And this immune activation is cofactor of developing of very disease. So currently the theory is that all human diseases, probably all of them, have two keys to develop. One is known or unknown etiological agent, like bacteria, virus, or unknown, so we don't know what's the factor for developing atherosclerotic plaque. And the second is chronic immune activation, which I just described you. So when HIV was infected, there was no wonder that's immune activation of the human body, and that's different disease developed. But now, with antiretroviral therapy, which becomes less and less toxic, but actually started 15 or 20 years ago even, HIV doesn't present in our body, at least not replicated. With all methods, we cannot really find virus when you are treated with this combination of these drugs I mentioned to you. So we thought that it's okay, that's it. However, all these diseases, cancer, cardiovascular disease, lung disease, bone fractures, cognitive decline, happens in these people 15, 20 years earlier than in normal population. All of the diseases are about immune activation. So the question is, and that's all kind of disease which we call aging. So if anybody want to study aging, that's a great model for aging, because we age normally in different speed. And your question? Yes. Just a second. Good. And but here you have a starting time point where aging starts. Yes?
There is theory that it's not about immunoactivation, it's about drugs causing depletion of mitochondria.
Yeah, I think that's a false theory. I'll come to it. So the question is, what is immune activates during all these 15 years? And that's probably the two main problems in this field. One is prophylactics, of course, not transmission. And the other is this problem, what causes immune activation, how to fight it. And that's a topic I'm involved now in over the last couple of years. So we don't have patients, but we study lymphoid tissue. So we take lymphoid tissue for surgery, and that's the main target of HIV in the body. and can keep it in the small fragments of 2 millimeters for several weeks, couple of weeks, 3 weeks. And this system has a great advantage because it has in vivo-like complexity. Whatever are cell relations in our body, the same is in this tissue blocks, of which we don't know even all the cell-cell interaction, may not know it for another 50 years, but they are there. So that's advantage, and of course there is disadvantage is the same. It's in vivo-like complexity because it's not human being, but nevertheless enough complex. So we infected this system with HIV and looked in the immune activation. And that is, we discovered it, other people confirm it. After HIV is infected, this tissue, there is a lot of immune activation, as shown by increase of different cytokines. Here I have, 12 cytokines which upregulate. That's evidence of immune activation. So now we treat this tissue with antiretroviral therapy. Here is control. So left is uninfected control. The next is HIV infection. So it increases cytokines. And on the left top, there is replication of the virus. So what happens when we add antiretroviral therapy? The red line, of course, virus is inhibited. Otherwise, why you need antiretroviral therapy? That's expected. And what happens with immune activation in our in vitro system? Immune activation remains the same. So in that case, we developed an in vitro system which mimics what's in human body. And now we can study what activates. It's not years, but nevertheless, it's in our time scale, it's 2-3 weeks, which can follow this tissue. And we developed different hypotheses, and one of that what you asked in a question. So the first question was whether the drugs themselves are immune activate tissue. Of course, these drugs are safe, they're tested, but for how many years they're tested? No agency would allow to test in a healthy human being any drugs for 20 years. Here we don't need any permission. Within this tissue, with 3 weeks we can use it. So what we did, we put ART in an uninfected tissue, and you see there is no additional immune stimulation. Tissue remains to be upregulated, the cytokines, so the drugs themselves, God save this inventor of this drug, are more or less not toxic in terms of immune activation. So maybe when activation, this is what I want to show you. There is immune activation is the result of pro-inflammatory effect of antiretroviral drug. No, the bars remain the same. There is no statistical difference. And we use this red antiretroviral therapy. The next we tested, maybe there is initial cytokine storm, which sets the time point somehow different. And although virus is not there, they still continue to do this. And the answer is no. We put the mixture of cytokines mimicking what happens in HIV infection on uninfected tissue, and there is not increase of any cytokines. So next what we thought, maybe endogenous viruses, some viruses which are in our body and come out because of HIV infection, and they continue, they don't are inhibited by ART, continue to immunostimulate our tissue. So most of them is cytomegalovirus, the most dangerous, and it really is reactivated, but after you retroviral therapy apply, it goes down. So the answer is maybe, in the long term there could be. And then we ask whether the proteins, in spite of the virus is not produced, some proteins come out of the infected cells and have some effect on pathology. So we added main proteins from the virus to uninfected tissue, and the left column is control, but you see whether we add important proteins which virus encodes, nothing happens. And the only thing we found that defective virions or extracellular vesicles which I told you in my first lecture, are really triggers this immune activation. So here is EVs from HIV-infected tissue, and the next is HIV from tissue under art, where no virus is replicating, and you see the immunostimulate tissue. So we think that that may be a contributor to in vivo. We continue to study this. Is my ongoing project. The first paper was recently published. And of course, we are looking in these extracellular vesicles what component of virus is there, or combination of components, which triggers this. So that's a problem which I think when I wake up in the night. So at the end, I will tell you a few words about prevention. Prevention, of course, would be the killing of the epidemics. So prevention could be, first of all, by education. So initially people thought that if you educate population about protection of sex, about from not having unprotected sex for infected people, who go for treatment, who go first of all to checking whether you're infected or not, that will of course diminish epidemics. Turned out that was not the case, and that a lot of what we know about psychology of human being. So first of all, people don't like to go to the doctors, don't like to go any checks. And the second, also people know about this, they behave very irresponsible. It's like we all know how many people from statistics dying on the road being hit by the cars. But I really don't know anybody who the statistic was so impressed that this person doesn't run for the red light or just cross anywhere on Rustaveli Prospect without any lights, just run across the cars. In spite we all know, because people are built such a way that they think that they never die, unless they die. So the same is true for any drugs, especially with something with sexual relation, which has some stigma. Turned out that people, educated people with a high blood pressure, 60% of them knowing that there is a threat of the stroke or infarct, they don't take these drugs, which the doctors told them to take. And that's a simple drugs which decrease your blood pressure. So people think that I live forever and don't like to take drugs. And the same is true, even more about HIV. People don't go to be tested and somehow close their eyes about probability of being infected and go into unprotected sex even when you don't really is a known danger. And finally, what's about vaccines? Vaccines would be a real prevention of epidemics. If you are given for a vaccine even once a year, I think that people would go there and being vaccinated, and that will be the end of HIV epidemics. So we know that the first vaccine was developed by Jenner against smallpox in 1796, long ago. Since we developed several vaccines which really saves humankind from different diseases. So what about HIV? When I came to NIH, National Institute of Health, it was mid-90s. President Clinton came to our institute to put a first stone in the building of vaccine center, which is now stands like here, and a lot of absolutely top-rate scientists work in this building, whom I know. And Clinton claimed that was May 1996, AIDS vaccine would be developed in this building by 2007, and gave a lot of money for this. So obviously Clinton didn't know anything about virus and probably doesn't know the difference between virus and bacteria, and he shouldn't. He was a president, not a medical office. But somebody wrote him this speech which makes this promise. We look in the calendar, now is 2023, there is no vaccine. Some people think that vaccine wouldn't be developed ever because of this multiple strategy which virus developed against our immune system. And vaccines, of course, mimics immune system. Some people still called no progressors are infected with HIV but don't develop AIDS. We thought about maybe we can mimic with vaccines the behavior of the body of these people. Up to now, that's complete failure. So we still hope that vaccine can develop. In science, like in life, you don't say ever no. But as Francis Bacon wrote, hope is a good breakfast, but it's a bad supper. So we think that we're in a lunchtime rather than supper and still have the hope. So anyway, right now some puzzle of HIV infection come together. And from my talk you can think that HIV infection, lymphocytes, death of immune system, microbial infection, activation comes to the puzzle. But basically, if you say honestly, our knowledge of pathology looks like more or less here, then the puzzle comes together. And thank you very much for your attention. I'm ready to any questions. Also, you can write to me, and I promise, as I did in my first lecture, that I answer all emails which are addressed personally to me. Yes.
Thank you for your presentation. First, based on the yesterday's lecture, I have a question about extracellular vesicles. What do you think, how we can use in treatment or in diagnostic maybe the extracellular vesicles produced by infected tissues?
Yes, diagnostics may be a simple thing, and I hope that it comes to practice, because at least for HIV, extracellular vesicles, which is HIV component, are released by infection cells before, several days before virus comes out. So in that sense, it's maybe the basis for diagnostics, and you can find some infection sometime earlier. Also, it maybe also can go into treatment, because I think that these extracellular vesicles are released to tell our immune system, which is slow, look, there is alarm, the virus will come soon, so be prepared. And since these vesicles carry viral proteins, it can trigger immune response earlier than the virus comes out. So that's one thing. And the second thing for diagnostic, but for the treatment, as I told you, there was the idea, of course, that you can inject these extracellular vesicles, and that will be like a dead virus in other infection, like poliomyelitis. You inject vaccines, initially there was dead virus, now it's live virus, which I injected to get us vaccination against polio. Maybe one day we can do it with vesicles, but that's far from practice.
When you talked about people who have the mutation of CCR5 coenzyme, right? There was a study, as I know, which developed treatment with CCR5 antagonists, but it wasn't successful. Do you know why it wasn't successful, and is it possible that in the long term we will have this easy, not treatment, but stopping of spread of the virus?
You see, this virus is so smart and clever that many trivia like this one, ideas, failed, which should work, failed when it comes in practice. So people, yes, try to make inhibitor of CCR5, but first of all, not in every, in the biology, no inhibitors goes 100%. So the same about microbicides, is also sometimes use the CCR5 inhibitor. So out of, I don't know, millions of cells which are protected for infection, there are some which this inhibitor didn't come, didn't bind, and it is known now that infection can go by one viral particles. So there are proved examples when one viral particles enters the human body with sexual intercourse, you can do it by DNA sequencing, it's sometimes enough to get infection. So no way you can inhibit 100% of CCR5. That's maybe one of the explanations of this. So the other strategy which was used and promoted recently, the other way, you stimulate viral production. So we know how to kill with antiretroviral therapy these cells which produce virus. So you make all the cells to produce virus, kill them in a hope that all this silent reservoir will be activated, also produce virus. If it would be 100%, that would be the cure for HIV. But it turned out, as in examples, that it's not 100%. Some cells remain as a silent reservoir, and it's continuous.
I have a question. So, since on HIV there are many attention across the world, and my question is about that it has high mutation rate, and I'm sure that people do some kind of modeling how it might behave. While those modeling might not be the true, but still, what is the prediction of this high mutation rate, how it might change? Can it be not treated but lose his activity or infection ability or so?
Yeah, that's a very smart question. And of course people thought about this. So this mutation is really a problem. And people tried to predict, make some mathematical model, biological model of how virus would mutate in a hope that something remains stable and not mutated. So against this, you can develop antibodies, and maybe you can, unlike your immune system, we humans in the lab can predict where virus mutates. Unfortunately, this work continues, so there is still hope. People start to find something which is stable in these mutations. And that's the hope of developing some treatment with antibodies against this virus. So you know that the same thing was in COVID, in SARS-CoV-2. In the Chinese laboratories, they did something absolutely meaningful. They tried to mutate this virus to predict where it will mutate in human population. Unfortunately, it looks, we're not sure, that this more pathological virus leaked out of the Chinese laboratory, and that's probably the beginning of world pandemics. But the idea that you should develop and predict, also in biological experiment, what mutates a virus and what stays stable is very meaningful. So people do work on this.
Thank you for the presentation. So my question would be related to CCR5. So if ever use the approach to transplant the bone marrow from CCR5 mutant people to
Yes.
what was the result?
There are 4 now cases, one in Berlin, one in London, and 2 I don't remember where. Sorry?
Germany,
Yeah. So when a person has leukemia and infected with HIV, and the treatment is transplantation of the bone marrow. There are reports, and first time by chance and then deliberately, the people who transplant bone marrow, they found the donor with this mutation. And all these people, as of now, and some of them are already several years, there is no HIV in their body, and they're healthy. One died by some different causes, absolutely unrelated with HIV. So this is a treatment. But that treatment, first of all, is terribly expensive, but that's probably not the main problem. It's very dangerous. So the doctors say that it's not good for general population of people with HIV infection. It will never be the general treatment because people die from bone marrow with pretty significant rate, especially, and nobody would prescribe to a healthy person to have bone marrow transplantation. But formally, that's a proof that delta 32 of CCR5 works even if you transplant this. As a theoretical and practical good example for science, but not good for general treatment.
And also 20 people died with this experiment.
Right. It's a very dangerous procedure.
But maybe it was to risk after immunosuppression reached certain points.
You see, nowadays, when we have such an efficient treatment of HIV, and people live much longer, in the old times, as I showed in the beginning, people dying in a few years. Now people live for decades. So, of course, nobody would recommend bone marrow transplantation with such a danger of death, while simple treatment with a combination of pills, you can prolong your life for many decades.
Do you work on broadly neutralizing antibodies, which is
Say louder, please, for this noise.
do you work on broadly neutralizing the antibodies? This is strategy.
Yes, no, I am in my lab now. We don't work on this, but I listen to my colleagues around. There is a promise that some antibodies are so broadly neutralized that they would neutralize all viral variants even after mutation. So that's part of the answer to your question, that these antibodies may foresee what would be the mutation of the virus, where its evolution goes. It's not treatment yet. And again, you see, since I work with HIV for a couple of decades, and I saw so many promises, so now I'm a little bit skeptical about new promises. Each of these promises says that, like President Clinton said, that in a few years we can treat people. As of now, we failed.
Even American administration, after discovering HIV in 6 months, they came and pronounced that in 6 months they will have vaccine from this virus, not only Clinton. And still we don't have it.
Yeah, some great people say that, some people say that, as I told that we always have to hope, but I'm not an expert in vaccinology, but some great experts argue, and some of them think that vaccine would be never, ever developed. Moreover, there was some vaccines which were started to be tested, and turned out they increase probability of infection. So Gallo compared this like a failure with a catastrophe with a Challenge space station that collapsed. So he thinks that that's a collapse and failure equal to this. And that's again well known why. That's like some microbicides with idea put on the vagina before sex, and they prevent transmission of HIV. And in all experiments in vivo, even on monkeys, that was success. It really prevents. How in real sex with women, it was complete failure. Why? Because it's also a little bit toxic for the epithelial vagina. Not really. In the in vivo experiments, you don't notice it. So 1 or 2 cells fell out of this protection level, and it's enough one particle to go inside to start infection, and you never again have 100% of cells protected with any treatment. So that was another failure.
You also mentioned that during childbirth, the danger that is for the child is, birth through vaginal birth, right? Because they take in a lot of blood. Wouldn't it be more safe? Thank you. Safe to do the birth via cesarean section than treatment with?
Yes, you're right. Cesarean birth is much less dangerous than the real birth. But now with this treatment, we really bring it to close to zero. I say that in developed countries, in Georgia, in all Europe, the probability is less, about 1%. And cesarean also can have 1% because of some contamination.
But isn't this treatment dangerous for mother or child?
No. For the short period, it's slightly toxic, but for the short period of 2 weeks, it's not really dangerous. And that's the greatest. So from 25%, we dropped to 1%. I think it's the greatest accomplishment of medicine in this field.
Is there any data about using microRNAs as a treatment?
Yeah, people are trying not only microRNAs, but the idea somehow to identify cell and cut out this fragment of RNA, DNA, which encoded by virus. If you develop this, that's really, you can save a person from this silent reservoir because it's not any more virus in your body. So again, in vitro, it works, but whether it will work in vivo, I'm not sure. First of all, you should identify these cells. Maybe you should go in all the cells with this instrument. It's promising. Right now, theoretically, it's the only way to get rid of virus in infected body. Whether it will work, whether you can reach all the cells, again, is a question of testing in vivo. We don't know, but the idea is there.
Is CRISPR used to prevent this infection?
Say it louder because the noise coming.
Is CRISPR methodology used to prevent HIV infection? Is there any data?
Repeat what?
CRISPR method.
CRISPR?
Yes.
Yeah, that's what I talked just a minute ago. So CRISPR, which cuts from chromosome particular region, is one of the hopes, of course, to cut out HIV genes from with CRISPRs. In vitro, it works with the cells. Whether it will work in vivo, that's a question.
Actually, in 2011 or 19, Kamil Khalili and another scientists developed this CRISPR-Cas9 and microcrystallization method, and they cured completely 12 mouses out of 20.
Mice,
yes.
Yeah, I had listened some time ago to a great immunologist and virologist. So that's the idea with general for pharmaceutics, to deliver something which is active, in that case CRISPR, but also different drugs, to the targets, to the cells in the body, to all cells in the body. He started his lecture with a joke. We have the drugs, medicines for all human diseases. If you would be a petri dish, I will treat you and cure you. Unfortunately, we're not petri dish, and to come to the cells which are true targets and true cause of disease would be very difficult. But maybe in some diseases, if you kill 90% of the cells which are pathologic, maybe it's a cure. In HIV, it's not a cure because I told you, repeat, that few variants which always left, it's enough to continue infection. That's the problem with this virus.
So I would like to ask regarding the diagnostics of HIV. So it's clear that PCR is quite specific and sensitive method, but as far as I understand, most of the methods used for screening are based on immunological methods.
Correct.
So how sensitive and...
Yes, it's very sensitive. In a couple of weeks you develop some antibodies, and with a type of ELISA you can really diagnose quite significant that person is infected. Not earlier, but it's possible to go with PCR. It's more expensive, but possible in most of the countries. And with PCR, you can be diagnosed really in a day or two that you're infected, in a couple of days. So that's an early. And this has some reason, because the earlier you start treatment, the more probabilities that you cure, you prevent disease progression. So that's something which is quite possible.
So with PCR you can detect the virus after 2 days after infection?
Maybe, I don't remember, maybe 3, but not 3 weeks or months. So RNA becomes, PCR of RNA becomes more and more, as you all know, more and more sensitive. So with the increase of sensitivity, you can develop it earlier and earlier in human blood.
I have a very short question. So is there still blood transfusion a main reason? Because as I know, in many countries now, Save Blood program is quite active, but still delayed. Because let's say in Georgia, we do even all reserves to have blood, they are tested little by little and it becomes safe now. So.
In most countries which I know, blood was tested for HIV, so transfusion is safe. In the beginning of epidemics, just when this diagnostics was developed, especially in France, which wanted to have their own diagnostic pattern, as I told you, by Montagnier, they delayed this testing of blood for transfusion compared to the United States, and this was deliberate decision of the Minister of Health to delay this introduction in the French health system, measuring of HIV in blood transfusion. And there were several cases when through blood transfusion people were infected. That minister went to prison for this. But nowadays, it was long ago, but nowadays in most countries there is blood was tested for HIV and it's safe blood transfusion.